Hello everyone. Sorry for the delay. Can you hear me? Hello. Yes, you can hear me. All right. So I'm using the microphone today, so it should be better than yesterday. Okay, let's get started. Sorry for the delay. I'm part of a project called SST, and I'm learning how to do a lot of coding. So that's what astrophysicists do. They learn how to code. So yeah, sorry for the delay, but let's get started. So hello everyone, and welcome to the daily space of Friday, October the 5th of 2018. I am your host, Dr. Andres Plazas, and I'm gonna bring you today the news from space and astronomy. So for the first story of the day, we're gonna be talking about the moon. And this is some news from the International Astronomical Union. The working group for the planetary system nomenclature of the Astronomical Union has today officially approved the naming of two craters on the moon to commemorate the 50th anniversary of the Apollo 8 mission. And the names of the craters are Anders Earthrise and 8 Homeward, and those are the ones that you can see on your screen a little bit if you squint a little bit. So this working group for planetary system nomenclature of the International Astronomical Union, this is the authority responsible for the naming of planetary features in our solar system. And previously these two craters were designated by other letters. And these new craters are actually visible in the foreground of that iconic Earthwise color photograph taken by astronaut William Anders, and that's the one that you can see in the lower part of your screen. And maybe it is a little bit too small right now on your screen to compare between the lower part and the upper part, but maybe if you find a larger version of the internet, you can actually see in the original picture the craters that are being named right now. You can actually make the correspondence between the two panels. And this is a very iconic picture. Some people have said that this picture has helped with the creation, for example, of the environmental movement, right? To make us self-aware of our place in the universe, of our home, the Earth, by looking at it. And this is one of the cool things about astronomy, that by looking into infinity, actually, in a way, we're looking at a reflection of ourselves. We actually get this cosmic perspective that allows us to, realize actually what our place in the universe is. So so this is, as many of you remember, the Apollo 8 mission took place in 1968 from the December 21st to December 27th. And after completing 10 orbits around the moon on Christmas Eve, they're broadcasting these images back to the Earth and giving live television transmissions. Then the crew returned to Earth and landed in the Pacific Ocean. And today, the International Astronomical Union has actually, approved the change of these names. And speaking of the International Astronomical Union, this morning I just received the news that I was accepted as one of the delegates of the International Astronomical Union. So that's cool. Yeah. Anyhow, but let's move on to the second story of the day, and this is actually very exciting news about Cassini. So these are some news coming from JPL, and this is a paper. This is a set of papers and a set of studies published in the journal Science and in the Journal of the American Geophysical Unions, and they're based on the findings from Cassini's grand finale. So we remember that in September of 2017, Cassini actually did a very close approach into Saturn, about 22 orbits between its rings and the actual planet, before actually plunging into Saturn and then just dying for eternity. And of course, this was done for planetary protection, right? We just don't want to send this probe we're in a place where we could think that we could have find some life or contaminating. But so despite the fact that in a way it was an emotional, it's always sad to say goodbye to all these spacecraft. It was actually very good for science, and now scientists are actually publishing the results that they got from this grand finale. So there are a lot of highlights actually from this study, and some of them are shown in this picture that you can see on your screen. But I'm gonna tell you of some of the highlights that are being reported in this press release. For example, they have found complex organic compounds embedded in water nanograins in rain down from the Saturn rings into the upper atmosphere. And for the first time, also Cassini saw up close how the rings interact with the planet and observe an inner ring particles and gases falling directly into the atmosphere. They have seen that some of these particles actually take some spiral paths along magnetic lines, which you can see in the green lines in the screen that in the picture that is shown on the screen. And this is a phenomenon actually called, they're falling into Saturn at higher latitudes, and this is a phenomenon known as ring rain. Another thing that surprised scientists is that they were able to see that the material that looks like the gap between to see what the material is of what looks like the gap between the rings and the Saturn's atmosphere. So they knew that the particles throughout the rings range from very small to very large, but the sampling in the gap actually showed mostly tiny and nanometer-sized particles like smoke, they say. And this is telling the scientists that it's some sort of unknown process is actually grinding up these particles. Cassini also revealed a previously unknown electric current system that connects the rings to the top of Saturn's atmosphere. That was something new. And in addition, they were able to discover a new radiation belt around Saturn, close to the planet and composed of very energetic particles. And they have found that while the belt actually intersects with the innermost ring, the ring is actually so tenuous that it doesn't block the belt from actually forming. And then there's a lot of highlights, but then another interesting fact is that they found out that unlike every other planet with a magnetic field in our solar system, actually the magnetic field of Saturn is almost completely aligned with its spin axis. Actually, the new data shows that the magnetic field tilt is less than 1%, like 0.0095 degrees. And as a comparison, the Earth's magnetic field is tilted about 11 degrees with respect to the spin axis. So this is actually a mystery, and the magnetic self of Saturn itself is a mystery, because according to everything that scientists know about how planetary magnetic fields are generated, they say that Saturn should not have a magnetic field, and it's a mystery that physicists and astronomers are still trying to figure out. So and then to conclude, scientists actually say that for the Cassini mission, the science return that we get from this grand finale orbit confirms that it was worth to take the risk of diving into the gap and skimming in the upper atmosphere and then actually looking at the edge of the inner rings of Saturn. It was a worthwhile effort. We sent a probe to we had not been before. And they even point out that almost everything going on in that inner region turned out to be a surprise. So this is a very exciting news. I haven't actually read the full papers. They're going to be published on Science. And I think they're behind a paywall wall, and maybe that's why I haven't had the chance to read them. And hopefully I will be able to find some free version online, or somebody who sends me the free version. But yeah, I'm advocating for open science here. But yeah, that was very interesting. I found out this morning. And for the last story of the day, we're going to talk about a new mission to find exoplanets. So yesterday we were talking about future missions such as WFIRST, that is going to look for dark energy, but at the same time is going to look for more exoplanets. Where we also know, of course, of Kepler that has given a lot of results, and we know of TESS that is already given results, already have found some candidates. But it turns out that the European Space Agency also has another mission that is called Plato. So Plato stands for planetary transits and oscillations of stars. And of course, it is an homage to the Greek philosopher Plato, and it is a medium-class mission in what ESA called their Cosmic Vision program. So the main objectives of Plato is to find and study a large number of extrasolar planetary systems with an emphasis in properties of terrestrial planets. And moreover, they want to find terrestrial planets that are within the habitable zone around stars that look like our sun. So a second objective of Plato is to investigate seismic activity in these stars, and then this will enable the precise characterization of the host star, and including in its age. So today they are announcing actually that there are agencies in Germany and in France that actually started. There are contractors that have actually started the industrial phase of the project and is moving ahead. So this is an announcement that was made at the International Astronomical Congress that is happening right now in Bremen, in Germany. Actually, the NASA administrator is there right now, for example. And yes, to give a little bit more of detail of this Plato mission, the Planetary Transits and Oscillations of Stars mission, it will be launched in 2026, and is trying to answer the fundamental question: does a second Earth exist in the universe? And this is, of course, one of the most exciting questions in astrophysics today. This is a spacecraft that will be built and assembled in France and the United Kingdom, but of course it will have contributions from many of the member countries of the European Space Agency, of the many of the states. This is a next generation exoplanet mission. It's going to monitor thousands of bright stars over a large area of the sky in the search of these little dips caused by transiting planets. So it's going to keep using the transit method that we were talking about yesterday, in which you're actually looking for how the light of a star gets diminished by the crossing planet in front of it, and then you measure how deep that dip is, and you measure the width, and then you're able to find out more parameters on this type of planets. Yeah, this is a very exciting development. It's great to have more of these missions. And then, as I was emphasizing yesterday, we're very much looking forward to a space-based mission that will use the microlensing technique that will allow us to find even more planets in the direction of the galactic bulge, and this will happen if WFIRST actually gets launched or not. So yeah, that was what I had to comment today. So I'm gonna see if you guys have any questions or any other comments. So I'm going back here and checking out the chat. Hello, Larry. Am I in Edwardsville? Larry's asking. I'm actually in St. Louis. This is where I live. It's about 40 minutes away from Edwardsville, St. Louis, Missouri. And I'm glad to hear that the volume is good today. So yeah, the microphone is working today. Yesterday, I'm sorry, but it turns out it was my fault. I forgot to tell the software to actually get the input from the actual good microphone. But I'm glad to know that you could hear my voice at a higher volume today. Hello, Guido, and hello, Honey. If you squint, they named the crater after you. In a way, yes, Anders or Anders. I had a friend from Denmark, who told me it is pronounced Anders. I don't know exactly how it is pronounced, this one, but yeah, it's the same root. Andres is my actual name. Anders is the name of the creator from the astronaut. So yeah, that'd be cool to have my a created name after me. So in my home country, Andres is a very popular name. Um, Steve is asking us there is a new reality show where flat earthers are trying to find the edge of the world. They will be so disappointed with the finale. It's not a cliffhanger. That was a good joke. Yes, the rings are raining. Fenry says congrats. Yeah, thank you. I'm happy to be part of the International Astronomical Union. I will get to vote whether we rename the Hubble law to Hubble-Lemaitre law. So we'll see. But hopefully I will get to make more important contributions to that. And the only magnetic field that lines up, yes. A new radiation belt, what causes that? So yeah, like coming back to the story on the radiation belt in Saturn. Yeah, I don't know exactly of what is actually causing this newly discovered radiation belt, so I don't have the answer right now from that question. But that's if you look at the screen right now, that's that colorful like rainbow-like ring that you see on the left, more or less. So does Saturn not have metallic hydrogen around the core like Jupiter? Is it too small? And then yeah, I'm not sure about that. I do think that Jupiter and the ice giants, they do have a metallic core, so I'm checking that out. But one of the things is that it is still a mystery to scientists, like where the origin of the magnetic field, what the origin of the magnetic field is. So scientists are fairly certain that while Saturn has a core, it is not a solid mass of rock or metal, but a liquid metallic mixture similar to all of the gas giants. So yes, there seems to be a core in Saturn, but maybe it's what you're saying, that maybe it is too small, or maybe we don't have the enough dynamical conditions to actually create a magnetic field. And even if we have a core and a flowing liquid, still there are all these dynamic complex processes that they don't actually guarantee that actually you're gonna have a magnetic field. But yeah, I mean, there is a magnetic field, but it's just they don't know exactly how it originates. And then I was gonna look at the chat, but I don't see. I lost my chat. Give me guys a second. I have too many windows open. I have like 50. Trying to figure it out. Let's see. Where did it go? Okay, I'm just gonna Google again. CosmoQuest to each. Yeah, sorry that because if I look at the little screen, I am not able to actually see the comments, so I have to go to the actual website. Thank you for your patience. Yeah, in the meantime, I was gonna say I won't be here next week. It will be hopefully Dr. Pamela from Australia. I'm gonna be in Washington DC for a meeting related to what is called the Decadal Survey in Astronomy and Astrophysics. And for those of you who are interested, you should Google it. Actually, this is a mandate that the United States government and some agencies like NASA, NSF, and the Department of Energy, they consult with the National Academy of Sciences, and they gather experts in the astrophysics, and they ask them about what the future for the astrophysics in this country should be in the next 10 years from 2020 to 2030. And right now they're making a meeting to ask for the opinion of early career scientists, and I was chosen as one of the delegates. So that's exciting, and I hope that I will be able to report back to you next week. I actually lost some of the chat, so I cannot see only the latest questions. So I can see a question by Larry. He's asking, how's yet undiscovered plumes from another moons? Can you repeat your question, the complete question, Larry? Sorry for that. Hani's saying congratulations. Thank you. And yeah, I encourage you to Google for the decadal survey in astronomy and astrophysics. And this has been since the 50s or 60s. This has been done, of course, every 10 years, not only in astrophysics, but also in solar physics, in earth sciences. And for example, one of the recommended priorities of this service have been the Hubble Space Telescope, the James Webb Space Telescope. The highest priority for the previous decadal survey was WFIRST, and for the space-based facility, and LSST for a ground-based facility. So this is an important document where all the experts in the field actually gather to write. So I'm not part of the actual committee who's going to write the report, but I'm part of a small group of early career scientists where we're going to bring forward what our opinion or what we think should be the priorities for astronomy in the next decade, and not only from the scientific point of view, but also from the human point of view, from the inclusion and diversity in our field. There's a big problem, unfortunately, in astronomy and in science on lack of diversity and inclusion, and sexual harassment reports. And I believe that there is our duty to do something about it, of course. Okay, I'm getting your questions back. Do NASA and ESA and others like JAXA coordinate so that their missions do not overlap too much or even complement each other? Yes, that's a good question, and actually they do. And for example, in the decadal survey from 2010, this is one of the things that they talk about. Like, we need to coordinate with international agencies and see what they're doing. And there's the scientific side of things where we want to do the best science as we can, of course. At the same time, you have the political side of things where every country and every agency, they want to do their own thing. But this is such a large enterprise, like exploration of space is such a difficult task that a lot of times you have coordination and cooperation between all the different agencies. And if you have ESA sending a space mission, then probably you're going to have instruments from NASA, or even right now in JAXA, the mascot instrument that is at the Ryugu asteroid, I think was built by the Germans or something like that. So you do have cooperation, and yes, like all these different missions that are proposed throughout the years, the different agencies look at what they're going to do and try to see how they maximize their efforts and how they're going to complement each other. Do we know in which way Plato will be better? Is it the guiding size or better instruments? I don't have the technical aspect of about Plato. That's a good question. It could be actually both, like more an improvement in technology and because they're gonna still be using the same technique, the transit technique. And it could be also maybe a better gathering area. I don't have the technical details on that. They are actually focusing their science objectives is focusing on Earth-like planets, so it's going to be a little bit more challenging. So I'm assuming that they're going to have to make a better control on the systematic errors, and of course probably have a better detector or a better type of technology to enable to see these smaller planets. Do you get to pick the instruments on space missions? Depending on the technology, this is one of the things that is also discussed about the available technology and the technology that will be needed to develop, and also not only technology but also the computational resources. And for example, with Usually you have first just science objectives that you want to study. An example is the James Webb Space Telescope. We want to learn about the earliest galaxies in the universe. But then it turns out that because of the expansion of the universe, if you use detectors in the visual range, like CCDs, you're not going to be able to see anything. The first galaxies in the universe get so redshifted that actually they're light, that you're going to actually detect them with the infrared technology. And then comes the practical size of things, like how expensive is infrared detectors are 1 order of magnitude more expensive than a CCD. A CCD is like $50,000, and an infrared detector of the same number of pixels is $500,000. So you need to start to figure out how actually you optimize your resources. Do you think Enceladus plumes may be replenishing the rings of Saturn, or has yet undiscovered plumes from another moons? And then can put in a good word for a sample return mission of the plumes of Europa? Maybe. The, um, so I'm not sure about the plumes of Enceladus. Yeah, they might be replenishing the rings of Saturn or not. I'm actually not sure about that. Can we give an opinion about the sample return mission for the plumes of Europe? So this is exploration of the solar system is not one of the topics that is going to be discussed in this decadal survey. I don't know exactly if there is like another survey where they actually talk about that. But in particular, in this type of survey, in the astrophysics survey, we're gonna talk about the origin of galaxies, the cosmic dawn, the origin of the universe, of the cosmological point of view. We're gonna talk about dark energy and dark matter, and not direct detection, but astrophysical detection, signatures of dark matter, and a field that, of course, is been growing up a lot lately, which is exoplanets, and Earth-like exoplanets more specifically. Would Plato also be good for finding exomoon? Yes, definitely. Like in the same way, we already are finding, like the story that we were talking about yesterday. We were talking about how people use Kepler to find like this secondary dip in the light curve of this candidate exomoon. And then people had to do follow-up with Hubble. But of course, we're going to be able to find more candidates in order that can tell us about more of these exomoons by looking more precisely into these secondary dips of these light curves. Maybe they will name a blob of dark matter after you. Maybe. Okay, everyone. All right. I hope I answered some of your questions, and we'll then call it a day for today. I think we have Dr. Matthew Richardson after us with Astro Office Hours. So this has been the daily space for today. Thank you so much for watching and for tuning in. And it's a lot of fun for me to talk about these topics with you. And as usual, please give us a like and please follow us. Everything helps. We'll be back next week, 1 p.m. Eastern Time, 6 p.m. London. And hopefully it works out for Dr. Pamela Gale. Otherwise, we'll try to find a different host, maybe Dr. Matthew. As I said, I will be in a meeting in Washington for the decadal survey, and hopefully if you guys are interested, we can talk about that next week and see how it went. So have all a great weekend, and see you next week. Bye bye.